Alright, so let's say in this situation here where we have a collision between a bullet and a piece of wood. And the question says, consider the collision above between a bullet of mass 5 grams and a piece of wood of mass 2 kilograms. The bullet collides into the wood and they travel together at a speed of v2 after the collision, causing the wood bullet system to be displaced a height of 3 centimeters. Find the initial velocity of the bullet, v1, and the final velocity of the wood bullet system to cause the displacement. To start, we can identify that this is a completely inelastic collision, since the two masses, bullet and wood, travel together after. As such, this means two things are true. The first thing, which is true for most collisions in general, is the total momentum is conserved, which means the total momentum before is equal to the total momentum after. The second thing is that for a completely inelastic collision, the total kinetic energy is not conserved. So the total kinetic energy before is not equal to the total kinetic energy after. And when the wood travels a height h, we can identify the bottom of the trajectory as the energy 1 and the top as the energy 2. If we know the total mechanical energy is equal to k plus u, so from traveling from E1 to E2, some of the kinetic energy is converted into potential energy, but we know that E1 is always equal to E2 because we can assume that the total mechanical energy is still conserved. So we can use this equation here to find the velocities. If we apply this to our example, we can start with the conservation of momentum given here. So for the two mass system, the bullet and the wood, the total momentum is going to be equal to the momentum of the bullet plus the momentum of the wood. So the momentum before and momentum after could be written like this. And then we can apply the definition of momentum equal to mass times velocity. So the momentum of the bullet is going to be equal to the mass of the bullet times the velocity of the bullet, and the same thing for the momentum of the wood. So we can convert the equation into an equation like this, and then we can first identify that the velocity of the bullet and wood after are going to be the same. They're going to be equal to v2 since they're stuck together after. And then we can identify that the velocity of the wood before is going to be equal to 0 since it's at rest. The velocity of the bullet for this is going to be v1. This is the initial velocity, which is unknown. If we plug these in, we can isolate for v2 by multiplying the top and the bottom of the right term by v2 over v2, which if we do that, we get this expression here. With this equation, we can know that there are two unknowns, v2 and v1. So we need to use a different equation, and that's where the conservation of energy equation comes into play. If we use E1 equal to E2, we can identify that at the bottom of the wood bullet system's trajectory is E1, and then at the height of h is going to be equal to E2. From here, we can plug in our general formula for the energy equal to U plus K, and then we can identify that U is equal to mgh and K is equal to 1/2 mv squared. But what is the mass? The mass is going to be equal to the mass of the bullet wood system, so it's going to be mass of the bullet plus the mass of the wood. Apply these definitions for U and K, we get this expression here, and then we can start by identifying H1 is going to be 0 because it's going to be at the bottom of the motion, and then V1, that's going to be V2 in this case, because since E1 is the initial point after the collision, it's going to be equal to the final collision velocity V2, and then the second height is going to be 3 centimeters because that's the final height of the bullet wood system. Then V2 is going to be equal to 0 because we can assume that the bullet wood system comes to a rest. Plug in these values, we get this expression here. We can plug in our knowns in the question for the mass and gravity, converting the 3 centimeters into meters to make the units make sense. And then we can compute the amplitudes in units of the term on the right, isolate for V2, do a couple calculations. We find this for the final answers. This is the velocity of the bullet wood system after the collision. What about V1? So we can go back to our momentum equation where we had two unknowns. But since we found V2, we can now solve for V1 by plugging in our known values as well as our new V2 that we found. And if we do that, isolate for V1 and solve, we find that V1 is equal to 307 meters per second. So this is the velocity of the bullet before the collision. We can note that if we look at V1 and V2, the velocity of the bullet is much, much faster. This means that the system loses a lot of kinetic energy due to the collision, because if we calculate the kinetic energy before, it's just going to be equal to the kinetic energy of the bullet, which if we plug in the known values, we get 736 joules. Since we know that the kinetic energy of the wood is 0 because the velocity of the wood's at rest at the start, and then the kinetic energy after is going to be equal to the total mass of the system plus the velocity 2 after the collision, which we plug in the known values for that, we get this. If we take the change in the kinetic energy, we can see that we lose a great portion of the kinetic energy.